Imagine a place where towering volcanoes pierce the clouds, whispering forests hide ancient secrets, and wild ocean waves crash against dramatic cliffs. This is the Pacific Northwest, a land of breathtaking beauty, but also of deep geological mystery. But this serene beauty hides a dangerous truth. The Pacific Northwest is one of the most geologically active places on the planet. Mount St. Helens, still scarred from its explosive 1980 eruption, has long been a source of fascination and fear.
At 8:32 a.m. on May 18, 1980, they get their answer.
We are directly above Mount St. Helens now, and there is no question that the volcanic activity has started.
And as if the volcano wasn't enough, there's something else lurking in the depths. Scientists have found a mysterious leak on the ocean floor just off the volcano's coast.
UW researchers say a continuous stream of warm liquid shooting up from the seafloor appears to be coming from the Cascadia Fault.
Could this be a sign of something far more sinister brewing beneath the surface? What dangers does this underwater enigma hold for the Pacific Northwest, and indeed the entire planet? A leak of volcanic proportions. Mount St. Helens is a volcano with a fiery temper, known for its explosive outbursts and dramatic flare. Scientists have been keeping tabs on this fiery peak for decades, well aware of its volatile nature and its precarious position along the Cascadia subduction zone. Now, this zone is where things get really intense. It's where two colossal forces of nature, the Juan de Fuca Plate and the North American Plate, are locked in a slow-motion collision. It's like a battleground for two massive chunks of the Earth's crust. The Juan de Fuca Plate is being forced downwards, grinding and groaning beneath the North American Plate. This relentless pressure creates a zone of intense geological activity, a breeding ground for earthquakes and volcanic eruptions. To keep a watchful eye on all this unrest, scientists have decked out Mount St. Helens and its neighboring volcanoes with all sorts of high-tech monitoring equipment. But while everyone was focused on the mountains, something unexpected was happening in the depths of the Pacific Ocean, just offshore. During a routine seafloor mapping expedition, scientists stumbled upon a bizarre discovery. A mysterious leak spewing out strange fluids from the ocean floor, right next to the volcano. This unexpected find has thrown a wrench in the works, leaving everyone wondering what this underwater enigma means for the future of the Pacific Northwest. So how did scientists even find this leak? Well, it all started with some unusual readings on thermal imaging scans of the ocean floor. The first clue came from unexpected thermal imaging scans of the ocean, in which scientists noticed a strange patch of seabed releasing warm fluid at an alarming rate. At first, they shrugged it off, thinking it was just another hydrothermal vent, something pretty common near tectonic boundaries. But here's the twist. It wasn't. As researchers dug deeper, they discovered this was no ordinary vent. The fluid escaping wasn't just hot water from the Earth's mantle. It was a cocktail of methane, carbon dioxide, and other gases typically linked to volcanic activity. Even more concerning, the fluid was loaded with chemical compounds hinting at a direct connection to magma reservoirs beneath Mount St. Helens. This wasn't just a weird find, it was a flashing red warning for geologists. A leak like this usually works like a pressure release valve for magma chambers, temporarily easing stress. But there's a catch. When the pressure builds up beyond what the system can handle, things can get catastrophic. We're talking seismic activity or even volcanic eruptions. And here's where it gets even more unsettling. The leak sits dangerously close to the Cascadia subduction zone, a place infamous for brewing megathrust earthquakes. These quakes can hit magnitudes of 9 or higher, shaking up entire regions. The presence of this volatile leak right near a major fault line could amplify seismic risks, making an already fragile situation even more dangerous. The makeup of the fluid spilling out adds another layer of concern. Among other things, it's spewing methane and carbon dioxide, both powerful greenhouse gases. Now, while the amounts being released right now are small compared to global emissions, this leak is like finding a crack in a dam. What happens if it gets worse? Methane in particular is a major player in global warming, trapping heat at a level far beyond carbon dioxide. A significant methane release from this submarine source could tip the already delicate balance of Earth's climate system. Scientists are now racing to figure out if this is just one rogue leak or part of a bigger, hidden network under the ocean floor. To get the full picture, we need to consider the history of methane hydrate destabilization. These hydrates, essentially methane trapped in icy cages beneath the seafloor, are stable under specific conditions. But a small nudge, say rising temperatures or shifting pressures, can cause them to collapse, releasing massive amounts of methane. And to make matters worse, the leak seems to be connected to a huge reservoir of methane trapped beneath the seafloor. If warming continues, whether from geothermal activity or climate change, it could trigger a chain reaction, destabilizing more hydrates and setting off a feedback loop of warming and methane release. With the volcano already showing signs of restlessness, this leak adds a whole new level of complexity and danger to the already volatile situation. So what exactly are the risks? Could this leak trigger a catastrophic chain reaction, unleashing earthquakes, eruptions, and even tsunamis? Is the Pacific Northwest sitting on a geological time bomb? The Cascadia connection. The environmental stakes are enormous, and the geological risks are just as alarming. The link between the ocean floor leak and Mount St. Helens suggests something unsettling. Magma deep within the Earth is on the move in ways scientists didn't predict. This movement could ignite volcanic activity, not only at Mount St. Helens, but possibly across the Cascade Range. Think about it. Could this trigger a chain reaction of eruptions? While the USGS publicly insists there's no need to panic just yet, the urgency behind the scenes tells a different story. Emergency teams are dusting off evacuation plans, and geologists are glued to seismic monitors, watching for any sign of escalating activity. The biggest concern is whether this leak is the prelude to a major Mount St. Helens eruption. History isn't kind on this front. The eruption of 1980 devastated 230 square miles of forest, claimed 57 lives, and spread ash around the globe. Now, with the area more populated and infrastructure packed than ever, the stakes are even higher. But it's not just Mount St. Helens making experts sweat. The Cascadia subduction zone, infamous for its earthquake potential, looms nearby. A megathrust quake in this region could mean widespread destruction, ground shaking for hundreds of miles, and tsunamis barreling into coastal towns. And here's a troubling twist. This leak might not be an isolated event. It could be a clue to something bigger, an interaction between deep-sea processes and seismic instability that we're only beginning to understand. To get answers, scientists are sending in cutting-edge robotics and deep-sea submersibles. These tools are mapping the seafloor, collecting samples, and watching the leak closely. Early reports are already raising eyebrows. The leak isn't slowing, it's growing. Its size and intensity are increasing, pointing to deep instability in the geological structures below. For now, all eyes are on the data, but the sense of urgency grows with every new discovery. A geothermal puzzle. The discovery near Mount St. Helens has the potential to change everything we thought we knew about the Earth's geological activity. This leak isn't just a curiosity, it's a sign that something far bigger might be at play beneath the surface. Could this be the start of a new era of tectonic unrest? As we continue to see the planet evolve, with plate tectonics and climate change interacting in unpredictable ways, this event could be the precursor to a series of global shifts. The ripple effect of this could span across tectonically active regions, hinting at a much broader pattern of disturbance. This leak serves as a reminder of how interconnected our planet's systems are. The cascading consequences of even a localized disturbance can affect the entire globe. Picture this: an increase in volcanic activity along the Cascade Range could release massive amounts of aerosols into the atmosphere, potentially changing global weather patterns and threatening agricultural stability. And if the methane from this leak enters the atmosphere, it could create a vicious cycle, further destabilizing methane hydrates and accelerating climate change. How might this domino effect reshape the Earth's future? Extreme weather events and rising sea levels could soon become the new normal. At a time when humanity is already struggling to deal with climate challenges, the leak serves as a stark reminder of the Earth's power and unpredictability. It forces us to confront bigger questions. Are we mere bystanders in a geological drama that has been unfolding for billions of years? Or do we have a role to play in mitigating the impacts? With new technologies at our disposal, can we adapt to a planet that is changing before our very eyes? Or are we at the mercy of forces far beyond our control? The more scientists dig into the mystery of this leak, the more questions arise. As they study the site, they are uncovering new layers of complexity that challenge our understanding of the planet. This discovery isn't just another geological event, it's a wake-up call. The Earth is alive, constantly evolving, and this leak near Mount St. Helens is just one example of how volatile that can be. Could we be facing a natural disaster that no one saw coming? For researchers, this discovery is the start of a race against time to understand what's happening deep beneath the ocean floor and what it could mean for the future. As the investigation unfolds, several surprising revelations have emerged. This leak is no longer a simple, isolated event. Data from deep-sea monitoring equipment has revealed that the leak is part of a much larger network of fissures that extend over a vast area, several square kilometers to be exact. This network forms what scientists are now calling a submarine geothermal system. Not only is it venting gases like methane and carbon dioxide, but it's also releasing superheated water and trace metals from the Earth's crust. So what could the long-term effects of this system be on the ocean's delicate ecosystem? The leak is starting to have noticeable effects on the surrounding ocean. Preliminary studies indicate that ocean temperatures in the area are rising sharply, and the water's chemistry is shifting. Marine life near the leak is behaving oddly. Some species are fleeing, while others are drawn to the area. This change in behavior suggests that something toxic may be leaking into the water, or there may be other environmental changes at play. Scientists are scrambling to understand why this is happening and what it means for the broader marine ecosystem. Perhaps the most surprising revelation comes from the isotopes found in the leak materials. These isotopes, which are rarely seen on the Earth's surface, are believed to originate from deep within the planet's mantle. This discovery is unsettling because it suggests that the leak is tapping into geological layers much deeper than anyone expected. How far down does this system extend, and what might we discover as we continue to explore? This revelation raises even more questions. Could there be unknown geological structures beneath the surface, just waiting to be unleashed? The deeper the scientists investigate, both literally and figuratively, the more complex the situation becomes. The interconnectedness of the fissures and the strange isotopic signatures are starting to hint at an underlying cause far more complex than typical volcanic activity. Some researchers are speculating that the leak could be connected to geological structures that predate the current tectonic configurations of the region. Adding to the intrigue are seismic tremors in the area, known as harmonic tremors. These tremors are often associated with magma movement and volcanic activity. However, the tremor patterns in this region are unlike anything ever recorded before. Some experts are starting to hypothesize that this leak could be part of a much larger geological event still unfolding. But is this a precursor to an underwater volcanic eruption? Most people associate volcanic eruptions with dramatic, fiery explosions and lava flows. But underwater eruptions can be even more destructive. The immense pressure of the ocean can contain the blast, but the sudden release of gases and heat could trigger tsunamis, destroy marine life, and send shockwaves through the Earth's crust. If an eruption were to occur near Mount St. Helens, the consequences could be catastrophic. Coastal communities would have little time to react, and the potential for widespread destruction and loss of life would be immense. As scientists continue to explore the worst-case scenarios, they are also trying to piece together how this leak fits into the bigger picture of the Earth's geological processes. One theory gaining traction is that the leak could be part of a superplume system, a massive column of hot rock rising from deep within the mantle. These superplumes are thought to drive major geological events, such as volcanic hotspots and the splitting of continents. Could this leak be connected to one of the most significant geological events of the century? This theory, while intriguing, also comes with some alarming implications. Superplumes are incredibly powerful and unpredictable, capable of reshaping entire regions over long periods. If Mount St. Helens is sitting on top of one of these superplumes, the future of the region could be far more volatile than we ever imagined. The question is, are we ready for the changes that could be coming? Global implications in the future of the Pacific Northwest. When the leak near Mount St. Helens was first discovered, no one quite knew what to make of it. It started as a puzzling anomaly, but now the environmental and geological ramifications are becoming impossible to ignore. The release of methane and other greenhouse gases is raising alarms, not just for the immediate region, but for the entire planet. What's even more alarming is the possibility that this leak could destabilize methane hydrates in the region, turning an already serious issue into something far more complex. As scientists dive deeper into their research, the leak's impact on the ocean's chemistry is also raising significant concerns. Marine ecosystems, many of which depend on stable conditions, are at risk. Even small shifts in temperature or chemical balance can create catastrophic changes. If the leak disrupts ocean chemistry on a large scale, we might witness the collapse of local fisheries, leading to the extinction of species that depend on these habitats. The interconnectedness of these ecosystems means that one small disruption could trigger a cascade of consequences, making the stakes higher than ever. Amidst these environmental concerns, the discovery of the leak has sparked international collaboration. Geological surveys and research institutions from across the globe are coming together to study the site. The findings so far have been eye-opening, with the realization that similar leaks may exist in other tectonically active areas, possibly unnoticed due to a lack of proper monitoring. This joint effort is not only shedding light on this particular leak, but also expanding our understanding of the geological phenomena that could be happening under our feet, often without us even knowing. The tools being used to study this leak are pushing the limits of underwater research. Autonomous underwater vehicles, or AUVs, are mapping the sea floor like never before, capturing intricate details, while remotely operated vehicles, also called ROVs, are taking samples and documenting high-resolution imagery of the site. These advancements in technology are providing an unprecedented amount of data, which could revolutionize our knowledge of underwater geological processes. But even with all this new information, several crucial questions remain unanswered. What triggered the leak in the first place? Could this be a sign of broader geological instability in the region? And what steps can we take to prevent future leaks? The answers to these questions could hold the key to understanding the bigger picture. One solution being explored is containment technology. The idea is to capture the gases being released to minimize their environmental impact while gathering valuable data about their composition. However, this solution comes with a massive logistical challenge. Implementing such technology would require significant resources, careful planning, and coordination. It's a race against time to reduce the environmental damage while also learning as much as possible from the situation. Researchers are also focusing on predicting future activity in the region. By studying seismic activity, gas release patterns, and other indicators, they hope to develop models that could forecast when and where additional leaks or eruptions might occur. This could allow for better preparedness and planning, ultimately saving lives and mitigating further damage. But while these efforts are crucial, they also highlight a sobering truth. We are still far from fully understanding the complex forces at play beneath the Earth's surface. As scientists, governments, and organizations work to address the challenges of the leak, the discovery serves as a stark reminder of the unpredictability of our planet. The Earth is dynamic, constantly changing, and governed by forces beyond our complete understanding or control. We may never be able to fully predict or contain these forces, but we must strive to minimize our impact and learn from the mysteries nature presents us. The leak near Mount St. Helens is not just an isolated incident, it's a wake-up call. It forces us to rethink our relationship with the planet, our responsibility to protect its fragile ecosystems, and our place within the vast web of life that sustains us. As we continue to uncover new information about this leak, we realize that it is not just a scientific anomaly. It is a reminder of the hidden forces that shape our world and a call to action for scientists, policymakers, and citizens to work together to address these environmental challenges. Looking ahead, the road will undoubtedly be filled with uncertainties, setbacks, and moments of fear. But in the face of these challenges, there will also be opportunities for growth and discovery. The situation calls for innovation and collaboration, pushing us to find solutions and expand our understanding of the planet. As the investigation into the leak unfolds, we are presented with a choice: to turn away and hope for the best, or to face the unknown with determination and courage. Ultimately, how we respond to this challenge will define not just our understanding of this particular leak, but our commitment to protecting the environment and securing a sustainable future for generations to come. So what lies ahead for the Pacific Northwest? Will Mount St. Helens reawaken with a fury? Will the ocean floor unleash its hidden wrath? And how will this impact the delicate balance of our planet? The answers lie hidden beneath the waves, in the heart of the Earth, and in the hands of those who dare to explore the unknown. What do you think will happen? Let us know in the comments below, and don't forget to subscribe for more earth-shattering discoveries. Thanks for watching.